to have here with us today a very special guest, Dr. Ellen Stofan. Dr. Stofan received her Bachelor of Science degree in Geology from the College of William and Mary and earned her doctorate from Brown University. She is a planetary geologist and was recently named NASA's Chief Scientist. She has received multiple awards throughout the years, including the Presidential Early Career Award. She has published multiple papers, book chapters, and books, including Planetology, Unlocking the Secrets of the Solar System, with astronaut Tom Jones. I'm honored to welcome here with us today, Dr. Ellen Stofan.
Good morning, everybody. I guess it's almost good afternoon, isn't it? It is good afternoon. You know, everybody's had this horribly cold weather, right, today and yesterday. And I got home from work last night, and my heat was broken. And it was so cold in my house. So I called, my husband called a heating guy, and he came to our house about 7:30 last night, and he stayed there till 10 o'clock at night fixing our heat. So by the time I went to bed, my heat was working again. Now I know a couple people who about a month ago, their kind of heating and cooling system broke, but the nearest repair people were 220 miles away. And they weren't just 220 miles away, they were 220 miles away down. So you know what those guys did up on the International Space Station? They went out and they fixed their heating and cooling system themselves in space. They did a big, huge spacewalk the day before Christmas. They spent all day outside the International Space Station repairing. They took parts out, they put parts back in, and they fixed it. Now I think that's pretty cool. I certainly couldn't have fixed my own heating and cooling system. And that's the kind of thing that we do every day on the International Space Station. The astronauts up there are doing amazing work. They're not only maintaining this amazing facility that we have that's orbiting the Earth every day, gathering all kinds of scientific data. They're doing experiments, they're reaching out to students all around the globe, talking about science and how science education is so important. Now at NASA, we don't just have the International Space Station. We literally study the universe, from black holes to polar ice caps here on Earth, to Mars, to the sun. We literally study every phenomenon in this universe, trying to understand it, and especially trying to understand how it affects us here on Earth. Obviously, we have a very complex planet with oceans and atmosphere, and everybody living on its surface, and our planet is constantly changing. NASA has literally tens of satellites around the world. We have instruments that go up on aircraft that are done right here out of Langley Research Center, that are going up and making all kinds of measurements of the Earth's atmosphere, of its surface, trying to understand how it's changing. Now this is all really important because it does affect us all here on Earth. All of us have had terrible weather and we have to understand it. And so it's important for you, as you grow up, not only to understand science, that hopefully one day you will be a scientist, which I hope of all of you, but also just so that we can understand what's going on. Now, when I was your age, I had a dream that maybe someday I would get to go to Mars as an astronaut. And I don't think that's going to happen, but for you guys, it possibly could happen. Right now we have a new rover on the surface of Mars. Does anybody know the rover's name on Mars? Right here in the front. Curiosity, that's right. And Curiosity right now is climbing a mountain called Mount Sharp. And what we're trying to do on Mars is to really understand what happened in the past on Mars. We know Mars was wet. We know at one point in the past on Mars it rained. There were probably lakes, maybe even seas on the surface of Mars. So maybe life evolved at some point on Mars. Not all the way to complicated beings like us, but at least maybe bacteria or small organisms that maybe by sending spacecraft there we'll be able to find. But I think really to find that evidence of life on Mars, it's going to take astronauts working on the surface of Mars, scientists, and that's where you guys come in. Because I think you'll have the opportunity about maybe 20 years or so from now to maybe go to Mars and be a scientist and work on these questions that we're so interested in. And we're not only trying to understand if there was life on Mars ever, we'd also like to know if there was ever life on Europa. Europa is a moon of Jupiter that we think has oceans underneath its surface, and maybe there's something living down there in those oceans. The other place we're looking for life is not even in our own solar system, it's beyond our solar system. We have a spacecraft called Kepler that over the last 2 years has discovered over 3,000 planets around other stars. Now just think, when I was growing up, we had 9 planets, then it went to 8 because Pluto got demoted, which I'm not very happy about, but we'll talk about that. And 8 to 9 planets was what we had for a really long time. Now we have thousands of planets, and hopefully some of those planets will actually have life on them. And pretty soon we're going to have another instrument that we launch in a couple years called the James Webb Space Telescope that's going to have instruments on board that can start studying the atmospheres of these other planets and saying, are any of those atmospheres kind of like our own? So that we can maybe start thinking, well, that's a planet that maybe someday we could actually go visit or go explore, not around our star, but around a whole different star. But on the International Space Station, which is so exciting today that you guys get to talk to people who are actually up in space, we're doing all kinds of exciting things to prepare for that, because one of the things we want to understand is if we send astronauts to Mars, what's the effect going to be on them? Does anybody know about how long it takes to get to Mars? In the back with the blue shirt.
About 6 months.
6 months is about the fastest you can get there, and sometimes you can find 8 months, maybe 10 months is the most, but hopefully you could get there in 6 months. Well, 6 months is a lot of time to be up without having gravity, and it turns out that as humans, gravity actually helps our bodies work. It helps our heart and our lungs, and really everything about us, our bones, are actually dependent on being in an environment with gravity. So when you take humans out of gravity, kind of funny things start happening to their bodies, not all of them very good. So what we're doing right now on the International Space Station is studying the effects of space on the human body, getting ready for that day, and making sure we understand how space affects humans so that we're really ready to take this trip to Mars, which hopefully will happen in the next, say, 10 to 15 years. So we're getting ready. We're learning how to grow food on the space station. We're learning how to have systems that can last all the way to Mars, how the astronauts can learn how to better take care of their homes so that if they're 10 months, 8 months away at Mars, they can fix all of their systems, not just their heating and cooling systems. So I'm so excited to be here with you guys today. I'm really excited to get this opportunity to talk, especially with astronaut Hopkins. He's a great guy and he's doing really cool stuff, and he was one of the astronauts that was out there in the cold of space fixing the space station a few weeks ago. So this is a great opportunity for you. And so thank you for inviting me to come down here today. I was trying to talk quickly because I thought maybe you guys would have some questions about all the cool stuff we do at NASA. Come on, somebody who's had a question. Back there I see an arm. Yeah.
How long do you think it'll take to get from right there to where we are right now? To get to Albatross right now?
You know, the space station orbits the Earth every, oh my God, I should know the answer. Every 90 minutes, I thought that was what I thought it was. It orbits every 90 minutes. So in an hour and a half, it'll be back where it was. And so I can't tell you exactly that, but just minutes. It's clipping along pretty quickly. Yeah.
So have y'all tried going, do you think anything besides that, do you think in the past did anything left on Mars?
Not, I think so.
Do you think that anything in the past may have lived on Mars?
Yes, I do, actually. And the question was, do I think anything in the past lived on Mars? And I think it did. And you know, you can say, well, scientists shouldn't think, they should go find out. And that's what we're trying to do with rovers like Curiosity and Opportunity and a rover that we're planning in 2020. We know the conditions were right for life to have evolved. There was liquid water, there was a source of energy which life needs. Those conditions stayed that way for a long time. Here on Earth, life evolved within a couple 100 million years of the Earth forming. So we know it doesn't take a long time, and we know all those ingredients were there on Mars, but it might be kind of hard to find the evidence, and that's why I think it's going to take sending astronauts there someday to find it out. Yeah. That's a great question. The question was, do the planets they just discovered, these 3,500 planets, do they have names? Each of them has what in my mind is kind of a ridiculous name. They have names like 3570GLBQ. So they have names, but they don't have very friendly names. And the reason for that is because they've found so many, they've just been trying to give them a designation so they can keep track of them. And there's actually something called the International Astronomical Union Commission on Nomenclature. And it's an international body that is responsible for naming everything in the universe. And I actually sit on the Venus task force, so I actually get to help name things on Venus. So that group will eventually be responsible. And it's an international group, so they try to make sure that stuff that gets named on planets represents all the countries and cultures of the world. That's a great question. She was asking if all these 3,500 planets we've just found are any in our solar system or near it. We're pretty sure we understand our own solar system. We've got these 8 planets, and then we have a bunch of things we call minor planets, which are like Pluto, and there's something called Ceres, and there's a whole bunch of those. But we have our 8 planets and all these minor ones, and then asteroids and comets. All of these planets that we've been finding are around stars. So they're at other solar systems. They're in our galaxy. They're all in the Milky Way galaxy, but they're outside of our solar system. And some of them are sort of close to us. In fact, there was just, people were talking in the news yesterday about one that was close in size to the Earth, that was relatively close to the Earth, but they're still so far away that we don't have the technology to be able to visit them right now, but hopefully we will someday. Light blue jacket. Pluto at all. Pluto is so cool, and we have a spacecraft called New Horizons that's going to get to Pluto in about a year and a little over a year. Pluto is amazing because it's what's called a Kuiper belt object, and the Kuiper belt is a belt of kind of like asteroids that are way out at the edge of the solar system. But that material is really interesting because it's what some of the very early material that formed in our solar system. So it's kind of like the building blocks of what other planets are made of. So by going and studying those bodies, we're actually going to learn about ourselves, which is actually why we study the planets in the solar system. We go out there and say, how can we look at these other bodies like Pluto, the composition of it, what it's made of, is actually going to help us learn more about how the Earth and how it formed. Oh, God, that makes it easier. Thank you. Right here. I couldn't even number how many things we studied. And we have sort of 4 primary areas that we study: the Earth, and so that's the Earth's surface all the way up through the atmosphere and even the Earth's interior. We study the Sun, our own star, because the Sun has amazing storms on it that affect us here on Earth, affect our communications. We study the universe, so how do stars form? How did the universe form? How do galaxies form? You know, galaxies collide, which amazed me. Our Milky Way galaxy, fasten your seatbelts, 2 billion years from now, we're going to collide with another galaxy. But don't panic, 2 billion years is a long time from now. So we study literally everything, which makes my job so fun, because I get to go and learn about all the cool stuff people are doing. Dark blue sweater. Yeah, you. That's a great question. Is Mars the only planet with more than one moon? Venus and Mercury are kind of the oddballs out because they have no moons. Mars has 2. But Jupiter and Saturn kind of take the cake. Jupiter and Saturn have tens of moons. They have so many moons they're hard to count. They are all complex little worlds in and of themselves. And in fact, some of their moons are nearly the size of Mars, so they have quite large moons. Jupiter has this really cool moon called Europa. That's the one that has an ice shell with this liquid water ocean underneath it. And I study one of Saturn's moons called Titan that has seas of kind of gasoline on it. And it actually rains this gasoline type stuff called methane on the surface. Right here. Each planet, that's actually a cool question. Do all these other planets that we've discovered, do all of them have suns? All of them except one of those planets is orbiting another star, so they each have their own suns. Some of their suns are bigger than our sun, some are brighter, some are smaller. Suns all have different, the stars all have different characteristics, but they all have a sun. But just this past year, they discovered a planet that was just like out wandering by itself. How sad could that be? And it turns out that people think now that when galaxies collide with each other, you can imagine that's quite a violent process. And they think in that process of galaxies colliding, that planets actually can get ejected from their solar systems and end up wandering the universe. Oh, makes me cry. Last question, I'm sorry. The dwarven planet. I went and saw The Hobbit the other day, now you're freaking me out. Pluto is a dwarf planet. And so a dwarf planet is a planet where you didn't have quite enough material and it never heated up enough to form the kind of layer cake structure that we have here on Earth. So when we have a planet that's just a little bit too small and didn't turn out quite right, we call them dwarf planets. So, all right, I know we're on a tight schedule today because we got to talk to those astronauts. We don't want to keep them waiting. So I'm happy to answer any questions you guys have after the event is over, but right now we got to keep going. Thank you.